To find the focal length of convex lens, materials required: a convex lens, lens holder, screen, and then object. I have considered electric bulb as an object and a meter scale in order to measure the distance u and v, object distance and image distance. To begin with the experiment, so before starting the experiment, we need to find the rough focal length of this convex lens. So we know that when object is at infinity, an image is formed at focus. So now we shall try to focus the window present over here. We shall try to focus window using this convex lens on this screen. We need to just move lens and the convex lens, and then we need to adjust such that a clear image is formed on the screen. Yes, now you can observe I have got an image of window. See, if I move closer, the image which we have obtained on the screen is blur. So we need to just move a lens front and back and then observe clear image of the window. Yes, so now this will be the clear image of window. So now with the help of meter scale, we need to measure the rough focal length. Yes, it is around 10 centimeters. So rough focal length is just measured in order to verify the experimental value is correct or not. So this rough focal length we need to note it down in a manual. So let us note down f is equals to 10 centimeter I got. F is equals to 10 centimeter I got. So when we do the experiment, we need to get f as a 10 centimeter in the result. So that is why we need to calculate the rough focal length. So now we will be doing the experiment. Okay, I have done an experimental setup where I have electric bulb, lens holder and a screen. So what do we need to do? We need to just move this bulb or lens, whatever. Okay, so when we are moving it, see, we get a clear image of bulb. Yes, so this will be the clear image and sharp image. Now we need to measure the distance from pole. According to sign convention, all the distances are measured from the pole. So now we need to measure a distance from this side. Okay, this point. So distance from this point to the object, this distance is nothing but what? So this distance will be object distance, and the distance from pole to this screen will be image distance. So let me measure what is the distance from object to the pole as well as object to the from pole to the screen, that is image. So here we can see the image distance is around 19.5 centimeters. So we will be noting down the values of u and v. So this is screen and this is pole in centimeter. Both are in centimeter. This is 19.5. So now let us calculate what is u. It is around 23. Yes. So in the same way you will be doing the experiments. In the same way we need to take few more trials in order to photograph. For example, let me change the object distance. Let me change. So now let us try focusing the, see, you can observe there is a blurred image. As soon as I am moving the lens towards the screen, okay, see, now you can observe a sharp image. So now again it will be a trial number 2. So let us measure what is the distance. So V is around 17 centimeter. So V is around 17 centimeter. We will note it down. And coming to u. So u is again around 31 centimeter. So now you can do the same thing around 4 to 5 trials, and you will be plotting a graph to calculate the focal length. So we have a formula. Focal length f is equals to OA plus OB divided by 4. So how do we plot a graph? We can plot a graph U and then V. Okay, you will get a U and V, you will get a pattern like this. So now you need to consider any point on this. Draw two lines perpendicular to x and y axis. So this will be OA and OB in terms of centimeter.